by Simon Karg. On paper, it's about something completely different, namely how does ideas of ethics and values, so to say, move up and down an ordinate, subordinate chain. But I wonder whether there isn't something in this that actually connects us both to the COVID-19 case and the climate crisis. But we'll know more about that once Simon has introduced his research. Simon, please take us away.
Yeah, thank you. Well, I guess we will see through the back end. Just give me a second while I share my screen with you. Also, just want to briefly check whether that works. That seems to work, right? You can all see my. Now I just want to see your faces again. Zoom. Ah, you're over here now. Sorry, I have too many screens open. There we go. Okay, right. So, yeah, as Andreas already said, I'm talking today about a project that's called Moral Leaders, Moral Subordinates. To kind of spoil already at the start, this is a study that is still ongoing. So I have pilot data, but I don't have full data yet. And this is due to kind of the inherent complexity that this kind of research project has, I guess. It just takes a long time to develop. And I thought that, okay, maybe what might be interesting then for you to hear about is to actually dive into a little bit of the more, I guess, technical details or sort of, things to think about when you want to do interaction studies online that require large-scale, numbers of participants, right? So just briefly, the kind of context for this, right, is that I'm interested in moral psychology, right? So I'm interested in how do people make moral decisions, and how do they act morally or immorally in all sorts of situations, right? And lately, I've been sort of focusing mostly on social interactions and instances of what's called collaborative cheating, right? So usually when we think about cheating or dishonesty, we think about one person cheating another person, right, or a second party. But what also happens, and often happens in organizational context, is that actually a couple of people come together and cooperate in order to cheat a third party, right, for their own mutual benefit. And that is what's called, or what I refer to as collaborative cheating, right? And so people have thought a lot about, okay, how in these sorts of collaborative contexts, how do people influence each other when making moral decisions, right? So how do these immoral cooperations, if you will, come about, right? So, right, that one person might, right, so you might have one cheater here, and that person kind of, by cheating repeatedly kind of signals to the other people, hey, let's cheat, and then they will also sort of come and start cheating, right? So it's a basic social influence model. In an organizational context, what's usually been argued is that if you have a leader at the top of the organization, right, like whatever they do matters a lot in terms of social influence, right? So the leader has a strong kind of downward influence on their subordinates, but there's been very few literature or ideas generally thinking about the other way around, right? This direction of moving from the subordinate to the leader, right? And this really is kind of the basic interest that we had in this research project, is about, okay, how, right, if we have a hierarchical team, how does like leaders influence subordinates, but also how do subordinates influence leaders in their ethical decision making over time, right? And so some of you might remember that now more than a year ago, I presented this study about so this is a lab experiment where we already started to think about this project, right? Where we bring people together And the idea was to study how ethical, if you pair an ethical person, so a person who's prone to be honest with a person who's prone to cheat, if you pair them up, right, and you make one the leader and one the subordinate or vice versa, and how they would kind of influence each other over time, right? And so we developed this kind of study, it's a two-stage study, which kind of has, at the first stage, there's an individual cheating task, right? So people here can cheat or not cheat. It's not so important, the text here, it's more about the logic, right? And after this individual cheating task, people get sort of paired up, and then they can then they cooperate in the second task where they then can cheat or also be honest, right? And what we found in this first study is very interesting. It might look a bit complex here, but basically the main idea is that the morality of the subordinate mattered much more than the morality of the leader, right? So this is a little bit unexpected, because usually you would think that the leader, who also in our design has sort of the most power to override decisions made by the subordinate, usually you would think that, yeah, they should have the strongest influence, right? But that's not what we found, right? We found the strong influence of the subordinate on the leader, or an overall cheating, respective to the morality of the leader, right? So this is kind of where I ended last year, right? Sort of saying, okay, yeah, we find kind of proof of concept that subordinates can shape behavior of superordinates or supervisors. But now we kind of need to, especially because we didn't predict this, we didn't pre-register this. So we wanted to replicate that and also better look at like the full 2x2, right? So if you think about ethical versus unethical leader, and then paired with an ethical versus unethical subordinate, right? So have a better look at that, right? Okay, yeah, you know, that probably sounds fine. Then the question is, okay, how do you, right? So like the plot I showed you here, right? That's basically a three-way interaction, right? So if you know a little bit about statistics, then you know, okay, a three-way interaction, that's hard to replicate or general to test, right, with high enough power, right? So I did a simulation of our model, right? And this here in the middle, that's kind of the relevant one. And if we want to have a decent power, then we need to get around 350 dyats, right? And if you want to have 350 dyats, then this is a study that we no longer can run in the Kobe lab, right? Because, yeah, that's 700 people, and yeah, it's just not possible, and especially not during COVID, right? So usually when you want large samples, is you go to Prolific, right, or mTurk, and you do a large online sample and be done with it, right? And that's also kind of the approach that we want to take. The only issue is, okay, how do you take such a complex like lab study design and translate it to an online space, right? So, and here's kind of I'm going to a little bit talk about the journey that we went through, right? So we are using this platform called O3. O3 is kind of an interesting, really interesting, platform. It's Python based. It's open source. Some of you who might be familiar with more economics things, they might know Z3, which is kind of the predecessor. Z for Zurich, and then tree for, I don't know what it actually stands for, but yeah, O3 is kind of a really nice way that allows you to conduct such experiments also online. The only issue is though that O3 is also built for lab experiments. So even though everything runs in the browser, it's not necessarily designed to do large scale experiments, but we made it work, kind of, I hope. So yeah, so here's the general experimental design, right? So that's the general logic. We need some kind of individual cheating task, then we need to pair up participants, cheaters and non-cheaters, right? And then we need to have this dyadic cheating task. And then and how does this look in O3, right? You need consent online, that's very important. We have an individual cheating task. I'll go into that later. So we built an external web page, a fake web page where people could roll a die and report the outcome. But we would always know what they actually rolled. So we could tell whether participants cheat or not, right? Then we need to introduce the task. We need to match people up, and then we have the task and questionnaires and payout end, right? And then we also need, right, and the crux kind of, to take things away, the crux kind of lies in the matching idea, right? So the problem is that participants on these platforms are not used to dyadic experiments. They're not used to do experiments that involve any other person. And in fact, I've run studies that mimic interaction studies online, right? That tell participants, oh, you're going to interact with another person, but it's always a bot. And participants also always expect that any other potential participants they run into are not really participants at all, but just bots, right? And so usually I ask a debrief question, right? So I ask them, do you think the person you played with was real or not? And around like 20% believe that they played with a real person, and 80% say, no, that was a bot. If you ask them like that, right? And the interesting thing is that, at least from the pilot data I'm having here, I get the same numbers. So even, so now I go through all the pain of actually having interactions, but participants don't think they're having a genuine interaction. At least they're very skeptical. Right. So maybe if it's interesting to you, right? So how does the individual cheating task look like? This is another sort of learning that we went through, right? So what is very interesting is that so individual cheating has been studied quite a lot, and there's a few tasks out there that are used again and again. And usually what's one of the most used tasks is this die roll task, right? So participants are told, okay, you're going to roll a die, and basically whatever number you roll will be tied to a bonus payout, right? So if you roll a 1, you get, for instance, 10 cents. And if you roll a 5, you get 50 cents. And then there's variations. So the one variation is where if you roll a 6, you get 0. Just because that is a little bit, that seems a bit unfair, right? Like I roll a 6, so I should get 60, but now I get 0. Like, why is that? So the hope is, or the idea is that usually, then more people cheat if they roll a 6, right? Because that seems extra unfair, right? And so keeping in mind, right, that the general idea what we want to achieve is, right, we want to match participants. So because we want to have like an equal share of ethical and unethical diets, right? Or like all 4 variations, right? So ideally we get a 50-50 split here. And that proves to be very tricky on prolific. So what has been observed previously already, and what my hunch was already going in, but yeah, it quickly was very obvious that participants on prolific don't cheat very much, right? So usually on mTurk and meta-analyses, you find that in these die roll tasks, usually around 50% of participants cheat. But I did like many pilots in different iterations. But yeah, I had a very hard time to get participants to cheat at around 50% level, right? So I used kind of every trick in the book, right? So we use the 6. If the 6 is chosen, then you receive nothing, right? Then we also show participants this graph of previous die roll reports, right? Where we show them, right? So this is what participants prior to you have rolled, right? And they can see, okay, only 3% of participants actually report a 6, right? So they can see kind of, we're kind of at that point already heavily hinting at, oh, by the way, you can totally cheat in this task, right? And then we built, I'm not sure, some of you might be familiar with random.org. Random.org is a website just online that lets you do all kinds of whatever you want, right? Like if you want a die being rolled, or you can draw cards, and you can do all kinds of things. So we built a fake random.org website and linked participants to that website to sort of give them a little bit more of a hint of anonymity, kind of where they felt, okay, like now I'm on a different website. Actually, they were still on our server. And yeah, so we tried to trick them with that. And we made it so that they always rolled a 6, right? So we knew that, okay, if they report a 6, then they're honest. And if they report something different, then they're probably dishonest, right? And now kind of comes the tricky bit, right? So now we have participants who might be honest and participants who are dishonest. And now we have to kind of match them, right? So now, and that is really difficult, because the main issue you have with participants is that time is money for them, right? So at least for the more professional MTurkers and the professional prolific people, they really like this, like doing these surveys is part of their income, right? So whatever they do, whenever they feel like, okay, I'm not getting further here, they might just bail on a task and just say, okay, this is, yeah, they just leave it, right? So what we try and do is we have this waiting page, right, where participants wait. They need to wait for the next person to arrive, right? So they play Snake here on this page, and we make them wait for a maximum of 5 minutes. Yeah, so the hope is that they stay on the page to wait. Yeah, so that's a little trick that we used. One unfortunate side effect is that how O3 is built is that waiting pages where participants end up and need to wait for other people, they reload once every minute, and that meant that our little Snake game also reset. And while testing, that was really annoying, because you have a score of like 21 or whatever, and then it resets, and yeah, that's not fun. But at least that's the best we could do for here, right? And so after participants have matched, they need to confirm that they're actually ready, right? Because one big worry is that participants might leave the page, right? But they still have it open, but they go do something else, go get a coffee or whatever, or browse somewhere else, and then they might get matched regardless. And then kind of the game starts, but they're not there, right? So they need to kind of say that they're ready, and if not, right, they get timed out, right, and they get moved to the end. The problem is, what do you do then with the other person who like said they were ready, but now they don't have a partner, right? They need to go back to the matching phase, and here's where O3 really breaks down. Like this isn't really possible because of the way O3 is built, and I can't really go into details. We have found a sort of workaround, but it's very hacky. It kind of works like 1 or 2 times, but then if that happens more than twice, then yeah, participants just won't get matched. So this is still a big problem, and I'm hoping to address that in future work. We will get a new assistant, very like sort of technical prone assistant, and maybe we can actually build like a really nice matching algorithm, or like a separate matching queue system, kind of like in online games, right? Like where you would queue up for a game, and then maybe you find partners, and if everyone's there, then the game starts, and if not, then you kind of get thrown back into the queue. But right now, this isn't really possible in O3. Right. But yeah, so, and after participants are matched, right, they play this cheating task, which is basically like the other matrix study that we did, right? So we have a subordinate who performs this matrix task. I'll have a picture of the task in a second. And then they can report their performance, right? And so here they can over-report more what they actually achieved. And so again, payout is tied to performance, right? Reported performance and not actual performance, right? So cheating makes sense because you get paid more, right? And so they report that to their leader, and the leader receives this performance report, and they can also check the performance if they want to, right? And then they kind of say, they report a final performance, and that leads to payoff results. And payoffs is always coupled or is always aligned between leaders and subordinates, right? So leaders and subordinates always receive the same amount of points. And that then gets repeated 8 times, right? So we have interaction between subordinates and leaders in the sense that subordinates can sort of offer a first, well, they do the task, right? And then they report, and there already they may cheat. And then the leader can look at it and can then think about whether they want to cheat even more or want to correct cheats from the subordinate, right? So we're here right now, right? So this is where we're at. And so here's how the matrix task looks, right? So it's basically a table of 12 numbers, right? And you have to find the 2 numbers that add to exactly 10, right? So in a given time limit. So you have 10 matrices and a time limit of 1 minute. And then, yeah, participants just need to find the 2. So here, my initial idea was to let you try and solve it. I'm not sure if anyone finds the 2 numbers. It's not that hard here. Yeah, I'm reading in the chat. The first 2 ones, right? That wasn't too difficult. So now you think you have, now just imagine you have to do 10 of those in 1 minute. That's obviously not really possible. And that's kind of the point, right? Like in testing, I like if I can get up to 4, that's really good. But yeah, so and then you can report how many you think you solved, and then the leader gets to see this, right? So they see, okay, your subordinate has reported to have solved 3. Come on, my pen has stopped working. 3 matrices, right? And we also like, and then they need to give their final report, and they have a button here they can click where it says show performance, and then they see kind of a drop-down menu of the performance, right? They see, basically they see this, right? So they see the solution and the answer next to each other. So it's really easy if they decide to click the button. It's really easy to spot whether or not like subordinates actually answered correctly, right? And yeah, so right, so they do that 8 times, and after that there's questionnaires and the usual stuff, right? Then there's one more technical issue. I kind of already said that, like it's similar to the matching. The other problem is that you have is if you do interactive tasks online is that you always need to think about during the time a participant is matched with someone else, you need to worry about timers and timeouts, right? Because essentially what shouldn't happen is that a participant gets stuck while the other participant kind of gives up on the task, right? Because that leads to problem. Participants get very angry and they write you emails, and they write emails to Prolific saying that you're a bad researcher, and then Prolific writes you emails that you're a bad researcher, and you don't want to go there, basically, right? And so from experience, there's different ways, right? But so basically all the pages you want to build, they have to have timeouts, right? So it needs to be very clear when a participant timed out, and then you need to have logics that kind of move participants kind of to the end, and that's all very doable in O3. Just maybe as a tip, if you plan on doing things like that, it's very important that you have things that have comprehension checks and any kind of effort in a way before you match your participants, ideally, right? So from experience, participants bail from a task during the comprehension check phase, right? So in this study, what we do is basically we have a comprehension check relatively extensively. So they have to solve a couple of matrices, and they also have to answer questions regarding like, okay, if you solve 2 matrices and the leader reports 5, like how many points do you get? And they have to solve all that. And that's, yeah, and this is actually the page where the most participants drop out, right? So it's very, very important that you kind of do all of this before you match participants, because after participants kind of go through that hurdle, it's much more likely that they will actually continue to the end. Yeah, so that's just a small tip. Yeah, and with that, we kind of I'm skipping that for now. With that, I kind of wanted to show you just a first brief look. As I said, this is really fresh work. So basically, this is data from yesterday, where I just ran a first pilot. So I'm super excited. So here, what I'm showing here is we have 9 dyads, right? So every little box here is a dyad, right? And we have the rounds on the x-axis, and then on the y-axis we have the matrices that are in orange is kind of what they actually solved, and then in blue we have what the subordinate reported, and then in gray we have what the leader reported, right? And it's super interesting already to see, right? So we have kind of honest dyads, right? Like this here is really honest, right? So participants kind of almost always report what they actually did, and then we have this very interesting group here where basically, right? So the leader always cheats to the full amount. So the subordinate kind of doesn't do anything anymore, right? And you can also see that we also collect timing data, right? So we collect the time spent on each page. So we know that here the subordinate doesn't even like attempt to solve any of the matrices because all of them are empty, and they just immediately click next. And so they kind of browse through the task, and they don't really do anything, right? Because they know, but the interesting thing is that the subordinate kind of never, so this is something I plan to look at, the subordinate never really tries to cheat themselves, right? So they know the leader is cheating, so they don't really need, and their answer doesn't really matter anyway, so they don't start cheating at all, right? So yeah, so this is cool. And then just another thing that is very interesting to look at is what happens here is that this is a very peculiar one, you might think, right? Because what happens here in this instance, right, is that the subordinate kind of solves 5, which is just insane that they got there. But then the leader corrects to 0. And here, this is weird, right? How do you explain this? And the answer for that is that the leader actually timed out, right? So here the leader actually didn't say anything. And because we need to have timeouts on each page, it counts every timeout, it just counts as a 0. So we probably need to, in the real data analysis, we need to get rid of that dyad, right? But yeah, so this is kind of the technical challenges of this of doing these kinds of things, is that yeah, weird things happen and you need to kind of look for it all the time. And yeah, and so I want to end with almost a call for help in a way, right? So I think that what we have here is some really cool data, and we'll record, we'll get data of like 700 people or 350 diets, and the kind of ways I'm looking at this data is probably okay, right? So, but I feel like there's some really interesting types of models that one could try and do that really tap into this interaction between different participants, right? Because right now what I'm doing is I'm modeling either the cheating of the leader or the cheating of the subordinate, but I'm not really modeling the interaction, right? And I know that there are models out there that can or that attempt to do that, right? So one example of that would be this kind of autoregressive latent, I forgot what the T stands for, but basically, right, so this is a structural equation modeling framework that has a random intercept, a random slope for kind of two participants or two variables, and then you can look at both, right? You can look at the effect. If down here we would have, right, the subordinate, and here we have the leader, right? And so now the idea would be, right, whatever the subordinate is cheating in the first task, right, influences in the first round is influencing how the leader is cheating in the first round, and then maybe they kind of move here, and you would need to kind of redraw the lines a little bit. But this is a model that I would like to run, but I really have no experience on how to do it. So yeah, I'm kind of looking for someone who has an interest in modeling complex interaction data, and just to maybe sit down with me and think through different options. So in other words, yeah, I'm kind of looking for a little bit of a fertilizer for the seed to kind of help it grow, maybe also into other directions, right? And with that, I just want to say thank you, and yeah, if you have any questions, just go ahead.
Thanks a lot, Simon. You know, modeling interactions is something that we have been struggling with for all the years that the Interacting Mind Center has been running, and I don't think we have come up with anything but very simple models, but at least some competences have been built along the way. So there might be someone in the wider community who can actually help to spell it out. My computer is back running again. It seemed to be not completely burned out. Probably a good thing these days here. We have time for a few questions or comments. So, Josh, do you want to comment a bit more on hierarchical models?
Nothing specific. It looks like a complex graph, but that's the fun place to start. With these sorts of things, a good way to go about it can be to see where you can reduce complexity with some sort of generative model of the behavior that you're interested in, rather than trying to keep everything within sort of a generalized linear framework, so that you're not necessarily thinking about interactions of interactions of interactions, but characterizations of processes that are then affected by an intervention. So I'm happy to talk to you about it sometime. This is sort of the fun for research for me at the moment these days. Yeah. When the heat of semester's over. Yeah, we'd be more than happy to talk to you about it, but nice work. It looks like very difficult to do interactive experiments. I'd been hoping it would be easier, to be honest. My strategy these days is to download old data, so other people who've collected data many years ago and then put it up on Figshare. But then I don't get to decide how the experiment works. Another thing we had a little bit of luck with for individual subjects was using the Kobe Lab participant pool on Gorilla or something like that. So basically setting up O-Tree and then getting people to do things at home anyway, but using our participant pool. Do you think
Right.
you'd have better luck with that, so that you wouldn't have this problem of professional experimental subjects or professional survey takers? So you'd have the same people that you would normally have in a lab with the same sort of norms that are in that community, but not have to be in the actual lab.
Right. Yeah, definitely. I think that would definitely be easier. And that would also be the way that I probably would have taken if not for size limitations, right? So usually the CoBiLab participant pool kind of maxes out at 300. If you're pushing it 400, also depends on the type of study, obviously, time and semester. But yeah, with 700 people and then people needing to be there at the same time, it's just probably not feasible. But yeah, there's no reason not to do this. And I actually talked to Dan also about it, and he's very open to do that. And then it's easier because then you could use the existing infrastructure, right, of time slots, and kind of matching participants up before they start the service. So you kind of know, and you have a way of contacting participants if something goes wrong, right? So you can kind of ask them to come again and sign up for a different time slot if their partner doesn't show up. So that makes a lot of things a lot easier. It's just that you give up the ability to collect bigger samples.
A principled model might get you to a lower sample size too. I mean, you could run simulations to see. Another strategy could be to use the CoBiLab as a platform. Dan would definitely be interested in this if you could feed more people into the CoBiLab subject pool by doing something like offering to give a guest lecture for a big econ course. If the teacher helps you get the students to participate in your experiment, and go to management and do the same thing, go to psych and do the same thing. With this sort of topic, you've got a bit of flexibility there. Just a thought, just to sort of try to get other sources of data collection to get you out of some of these headaches.
Yeah, thanks.
Yeah,
but now that so one thing that I also want to just want to say, right, that now that I've solved a lot of these technical issues, right, so my hope still is that we can improve the matching algorithm. And with that kind of out of the way, I do see a lot of potential in this, right? So I do see that, I mean, of the limited pilots that I run so far, it's actually rare that participants time out during the matching phase, just because it kind of, yeah. So all the steps leading up to it, like trying to control for comprehension check failure and to like try to see that to filter participants who are actually engaged. It kind of works fairly well, I would say. So I think there's a huge potential here.
You still have to throw away a bit of data with people not believing that they're actually having a partner, whereas CoBiLab, everybody believes that they have a partner because we have this policy of never lying to anybody. So that could,
right.
I mean, save you, not necessarily save you some money because CoBiLab participants probably cost more, but just as a thought.
Yeah, no, that's certainly true.